What is physics? And how can we use it to describe the world around us? The motion of bodies as they travel from one position to another. I'd like to take a minute to talk about physics as the study of momentum. Say we have a stationary ball. Newton tells us this ball will remain at rest until we apply a force which will increase its momentum. Once the ball is in motion, it takes an equal force to decrease its momentum and cause it to be at rest once more. But how do we define momentum? Momentum is defined mathematically as the product of an object's mass and velocity, or speed in a given direction. It is, then, an inertial quality of a body. Momentum tells us how difficult it is to speed an object up and slow that same object down. A four-door sedan barrels down the highway at 70 miles per hour. This car has a large quantity of momentum because it is moving quickly and contains a lot of mass. However, a sedan which is not moving has no momentum since it has no velocity. And a sedan moving at 5 miles per hour has less momentum than a motorcycle moving at, say, 70 miles per hour. To achieve the same momentum in a less massive object, we must increase the velocity of that object. As related to our example, in order for the sedan and motorcycle to have equal quantities of momentum, we must increase the velocity of the sedan to, say, 12 miles per hour. Somewhere in the mid-1600s, Isaac Newton discovers that momentum is conserved before and after an event occurs. This is sometimes referred to as Newton's zeroth law. It helps to think of it this way because the other laws sort of fall out of this concept of conservation of momentum and come together very nicely at the end. In fact, you already know the first law, the most intuitive of the three. An object at rest will stay at rest unless acted upon by a force, and a moving object will not stop moving unless a force is acted upon it, opposite its motion. But what is Newton's second law? You may have seen it in school written as F equals ma, or force equals mass times acceleration. This works for solving problems as they are worded in high school, but acceleration is a much less intuitive quantity than momentum. Newton liked to say that the force exerted on an object is proportional to that object's change in momentum. We exert a force on a stationary object, its momentum changes. We exert a force on a moving object opposite its direction of motion, and we decrease that object's momentum. We can write this equation as force equals change in momentum over change in time. The letter d's are a part of a function in calculus called differentiation, really just a fancy word for changes over a short period of time. You'll find that if you consider most scenarios in terms of momentum, the physics becomes much more intuitive. Thanks for watching.